Hello everyone, this is Karan Kumar. Welcome to the Druid Summit talk. Excited to see you all here. This talk is regarding async query and querying from deep storage, one of the features that graduated in Druid 28. A bit about me. This I'm Karan. I am an engineering manager for the Druid query team in India here at Imply. I have about 12 plus years in distributed systems. I am a PMC member of Apache Druid. I have also been a contributor to various Apache projects like Kafka, Trinio, Pig, and Falcon. So, so what are the problems we are trying to solve with async query and query from deep storage? Let's dive a bit into that first. Let's talk about storage cost. S3 is one of the cheaper alternatives. We pay about 0.032 GB per month. Um, for an EBS, we pay about zero point zero 0.08 GB per month, and for a M6 for a metal machine, we pay about 0.73 GB per month. This is about 22x of S3. This is more important for Druid because we need compute to be co-located with storage for us to enable querying for it or on it, and that is that's a bit expensive. Along the same lines, we have seen that about 75%, about 75% of the data is accessed quite frequently, which is generally the recent data, let's say last 5 months or maybe last 10 months. But for some use cases like having computing year on year um, sales numbers or sales aggregates, we have to keep the raw data somewhere, and that is where the TCO costs of Druid balloons up. Also, if we are dealing with large data, sometimes query take longer to run. We have multiple layers like ELB, we have the Druid router in between. Results can be in GBTB range. Since we have a sync endpoint for Druid because it's meant for speed, um, the Wi-Fi connection needs to be it has to be on for the entire duration, and if it disconnects, you basically lose all the progress. Merge buffers is something that is very contentious, and since all the query pools use the common merge pool, if you have a long running query and that is running merge using merge buffers, then there is obvious resource contention which you don't want. And in any case, we don't want the slow queries um, to make our dashboard queries or our faster interactive queries slower. So what do people do for the current for to solve for this, right? So to to offset costs, they basically do historical tiering, and what they do is for the hot tier, you let's say for the last 3 months, you have the replication factor as 3, and for the data for the last year or maybe 3 years, for 3 months to last 3 years, you put it in a cold historical tier, which is basically replication factor of 1 and which has a bigger disk but less CPUs. So this results in lower cost per GB. It has slower queries because you have less threads and less concurrency because you have less replication factor. And the hot tier is, higher cost per GB, faster queries, and higher concurrency. How do we tune Druid for long running queries? So we've seen uh, customers use broker tiering. Um, we have a default query timeout. We you can set it to maybe it's 5 to 10 minutes. I think 10 minutes by default. You can set it to 15 minutes, maybe 20 minutes. You have a max query time that can be set per query. You have a read timeout on the routers and you have a read time on the brokers. The router's read timeout is the amount of time uh, the routers wait for reading results from the broker, and the read timeout on the broker is the amount of time brokers wait to read stuff from the historicals. And there's also ELB timeouts. Uh, with all of this tuning, you can probably tune the Druid cluster to run long running queries for maybe 15, maybe 20 minutes, maybe 30 minutes. But let's say if you want to run for hours or days, right? What do you do? Um, so here is the new feature that we built, which is called async query and query from deep storage. And let's see what's it about. So, so like I was saying earlier, like query accessing older data are usually long running, and what we want is always having that we don't want to impact the short running queries ever. So in short, we don't want to cause a traffic jam. We want the buses to be in a different lane, and we want the Ferraris or the Lamborghinis to be in a different lane. This is a hard problem. There's a entire, a lot of people working on scheduling algorithms. How Druid solve this is you uh, basically with resource isolation. What do I mean by resource isolation? Let's dig into that. So we expose a new endpoint. It's called the SQL statement endpoint. And what it guarantees is instead of the normal broker historical route, it goes via the ingestion tier, which is the middle managers and peons. And it helps us running long running tasks because by default bash tasks are designed to be long running. They're designed to be high throughput, and we can make them elastic if we have a autoscaler attached to the overload. Uh, and this gives us uh, resource isolation. What is the complete flow of the query? The query is submitted to the broker to the new endpoint. It basically launches a, a MSQ task via the overload, and the overload launches first the controller task and then the worker tasks. The worker tasks download whatever stuff is there from deep storage, and then they also contact the real-time node for whatever results are there for the real-time nodes. So the controller node behaves sort of like a broker, and then whenever they are done, they write the results back to deep storage, and then we have configured the broker to now talk to this deep storage location where in any whenever it's fetching results, it basically goes to the deep storage location, sees what are the results, and uh, fetches it back. S- So, so with this, what we needed was we had the capability to query stuff, but we wanted users to be able to query deep storage segments. So that is where the query from deep storage feature got built. And now with this, you can now query segments that are only in deep storage. So what that means is we don't have to load that data on the historicals, and then you can basically query a lot more segments without having a increase in total cost of ownership of Druid. The use cases for Druid for query from deep storage are, it complements Druid for having a longer data retention window. With this, there are use cases where you don't even want to have a retention window. You can always have the query data to be data which are in segments to be always queryable. Um, we want the users to be access older data at a lower cost. We want users to have an ability to have large result sets or and export data from to it. Um, we want to be able to run uh, stuff like high cardinality group bys, which we couldn't run in the native engine. Um, and we want to be able to run long running queries. Uh, the how we run high cardinality group bys is basically we always fill and we don't use the merge buffers. That way we are able to that way we are able to handle a lot more cardinality on the group by side. Um, this is not a complete DWH replacement though. Um, so if you are looking for a ETL tool or a complete DWH solution, then there are better tools available here in the market, more mature tools available in the market. So how do we enable this new feature? We enable it via load rule, and you should have the MSQ extension already loaded up. So there are two steps. Um, Once you enable this, you would start seeing the web console saying that your data source is about 83%. It's whatever percent async, and the other uh, rest is sync. Uh, we'll dive a bit more into this when we demo this. Async query. Since we're using the MSQ engine, we uh, we always spawn a query, and then that is tracked via the segment tasks UI. So you can basically punch in your query ID, and you can see what's going on with the query. You can see the logs. You can see the metrics. Like we discussed earlier, we write out the results to durable storage. If the user wants to have a large result set, the results are stored in the frame file format, um, and this basically helps us lay the foundations for temp tables in Druid. This also, as we'll see in the next example, is it helps us export the data to whatever data the user wants, and the result is exposed via broker API. This is um, this is less strenuous for the broker because you're not running any uh, you're only using a Jetty thread on the broker and not using contentious things like merge buffers on the broker to get the results. So this is a lower footprint usage of the broker. The query results can be found. They're all separated by they have the query ID and then whatever stage wrote out the result. Uh, there there's a new paginated endpoint. So by default, the page size for that endpoint is 100k rows. It can be adjusted via context parameter rows per page, and we store results uh, until the task logs get purged out. So there are no net new settings that you need to do to configure persistence, and there are support for all the result formats currently available at the SQL endpoint. One difference is that you never run the query again. You can basically while fetching the results, you can basically say what is the result format you want, and we are able to change the result format while we are streaming the data from 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 S3 or um, Azure or GCS. So let's look at the demo. The proof is in the pudding. So so I have the taxi dataset ingested. It's a 60 million dataset and I'm running on my local laptop. If I run the normal SQL native engine, the native engine has about 7.3 million rows. Um, for the for the MSQ engine, let's just run this query. And here you can see uh, we just use the MSQ engine for this. And I'm using indexers, so it's a bit fast. Um, so for while this runs, uh, we can look at the data sources tab and see that um, the taxi data is about 83% async and we have about 1500 segments. How do I configure this? I just go here, click on edit attention rules, and I just use a load rule to configure whatever I want to be not loaded on the historicals. Um, so yeah, I so the query would have run. Yes. So if you see, uh, so we have one result set. It took about it's written to one page, and it took about 23 seconds for this. Um, um, I also ran a select query. The select query takes about a minute and 30 seconds for writing out 5, 10, 500K results. And the way you can download these results is basically through the uh, whenever we write out the results, we write it out in pages, and the pages are by default 100K. We use a s- we use we use a data sketch for estimating the for basically cutting the results out. So they are not guaranteed to be 100K. They are, we just try to be around that number. So as you can see, we have about 510 uh, 500K rows, and each page is about 84K uh, 84K rows, and I can basically go ahead and download it, and it basically gets downloaded. This is at this is the size of the frame file, and the not the file we are eventually downloading. So here you can see we downloaded a 1.7 MB file. Um, and there are various options here: array of objects online, array of arrays, and CSV. All right. So the feature is GA. It's out in Druid 28, and we already have a nice tutorial where you can uh, try it on your own clusters. The link is provided here. So a bit of robot performance for the async queries, we take about 5 seconds to 20 seconds to start up. That is because the workers have to start, and then for the data has to be downloaded. In the current Druid, there is no cost because it's already locally available. But for async, we have like 5 to 10 seconds. It can be more depending upon how long the data range is. And then the running can go from 10 seconds to however many hours. Um, it can go up to hours, days, and there is also whenever you want to fetch results, there's also cost. Take about 4 to 5 seconds to fetch the data because you have to go to the storage and fetch the results from there. What this does is basically breaks down the cost of your Druid cluster, and it can be um, paired with auto scaling and ingestion slots. Um, you can basically decrease the cost of your of your uh, Druid cluster. If you basically make the last data for the last after, like, keep the last 6 months data on hot, and the rest you can push it off to deep storage only and not load it on the historicals. There's certain caveats. Currently, we need one segment to load because that is required for the broker to plan the query. This uh, this this limitation will go out. There's a lot of work happening on the segment metadata, and that would help us, get away from uh, this caveat. We also need enough slots to run. So if there are not enough slots, we basically time out in 10 minutes. And from our benchmarking, what we have seen is for 1 million segments and for with around 9 columns, the there's there's a bit of we need more memory just to store all these segments. So the broker requires about 300 MB more, and the coordinator requires about 1.8 GB more. What we have also seen is people not sizing their metadata DB enough for this increased number of segments. So whenever you try it out that feature, please be mindful of just look at your MetaDB stats and see if the read times are increasing, or yeah, if the read times are increases on for your metadata DB. What's the future work for this? Um, we want to get faster. So for that, not we want to start uh, streaming results back to the broker. We want to build features like partial segment download, where we don't fetch the entire segment but only part of it, and whatever we have fetched, we want to cache it so that whenever the query comes again, uh, we just use the cache that is already available. Um, so yeah, so partial document download, caching, and we MSQ Interactive, which will is a newer way of running MSQ, where we will support result streaming at we will support pipeline execution. The features that we want to start that we want to build out is selecting into an external Parquet. So we are able to export data to, let's say, a Parquet format. Thank you. That's it.